Hey guys, so we'll see the introduction to reinforcement learning. Uh, have you ever wondered how machines learn to take decisions without being explicitly programmed, or how do they adapt to new situation and improve their performance over time? Well, the answer is in reinforcement learning. But what is it? It's just a powerful AI technique that has revolutionized the way we train machines to solve complex problems. But what is the problem? Like traditionally, we used to use machine learning algorithms for which generally relies on supervised technique or unsupervised technique, where we give the data as labeled or unlabeled respectively. So while these methods have been highly successful, but they fall short in situations where the data is scarce or the environment is constantly changing. So in these cases the reinforcement learning comes into the picture. So so like in the introduction part we will going to see like state, action, reward, environment and agent, basically the dance between these five main elements. So let's unravel these concepts with some everyday examples. First up, we have the state. Think of it as the current situation or configuration of environment. Okay, so it's like the snapshot of where things stand. Okay, like in a game, a state could be the position of all the chess pieces on the board. That could be the state. Or else imagine you're playing a game of tic-tac-toe. The arrangement of x and zeros on the grid will represent the state. It's like just taking a snapshot of the game at any given moment. So like in the realm of computer science, state could represent the current condition or variable in our program. Like if you're building a weather app, a state could be the current temperature, humidity and wind speed, etc. So imagine coding a game where you track the player's health, ammunition, and levels. So this variable make up the state, capturing the current snapshot of the game. So yeah, that's basically the state. Then now let's talk about action, which generally what it speaks. The word speaks itself. Like actions are the moves or decisions the agent can make in the given state. Like going back to our tic-tac-toe example, placing an x or an zero in a vacant space could be an action. Picture this: you're driving a car, okay, and you come to an intersection. So now your action could be turning left, right, or going straight. Each choice is like an action in the grand game of navigating the roads. So, like basically, actions are the moves or decision our agent like takes. Then it could be something as simple as changing a variable's value or executing a function in a program. So in short, like in coding we can consider a chatbot that recommend movies. So the action might be suggesting a movie based on users preferences. So the code decides what action to take, like which shapes the user experience. Then comes the reward. So this is the positive or negative feedback the agent receives after taking an action in a certain state. So in a driving example, we can see a smooth ride might earn you a positive reward, while a traffic ticket could be a negative one. Then think about playing a video game. Every time you defeat a level boss, you get a reward, maybe extra points or a new power up. That positive reinforcement keeps you motivated to conquer the next challenge, right? So But in the coding universe, rewards are the feedback our algorithm receives for taking certain action. It could be increasing a score, or achieving a goal, or successfully completing a task. Okay, then think of a training spam filter. So when the algorithm correctly identifies and filter out spam emails, it gets a positive reward. This reinforcement helps it get better at the task over time. Okay, now let's zoom out a bit and look at the big picture, the environment. It's the entire playground where our agent and all the action takes place. In a driving scenario, the streets, traffic signals, and other vehicles are a part of the environment. In real day life, like take gardening as an example, the garden is your environment, and you, the gardener, take actions like watering, planting, and pruning. The environment reacts with the growth of plants, pests, and changing seasons. The environment in coding is the broader context in which our code operates. So, like it could be the database, the network, or like any external factors that influences our program. So, for example, let's say you're developing a stock trading algorithm. Okay, so the stock market data, economic indicators, and news feeds from, like it forms the environment. So your algorithm interact with this the dynamic setting. Then last but certainly not the least, the agent. That's you, or an any entity making decisions in the environment. In our example, you driving the car or playing a game are the agents. Simple. Let's think about a robot vacuum. The robot moves around in your living room, and the living room, which could be your environment. The robot is the agent, and when it successfully cleans a spot, it gets a little reward. So, like, consider a self driving car algorithm. The code could be your agent, which processes the sensors inputs, make decisions on speed and direction. So this is its action, and receives feedback based on how well it performs in traffic rules. This could be your rewards. So this is what, like, the introductory part of the five elements of reinforcement learning. Now let's talk about the goals of reinforcement learning. What goals does it achieve or tries to achieve? So first is the optimal policy. So the primary objective is to determine an optimal policy. What is optimal policy? It, you can basically say in simple terms, it is a collection of rules. It instructs agent what action it should take in each state of the environment. Right. Then after getting optimal policy, then it tries to maximize its expected rewards. So we see in our previous slide, like it takes a positive or negative feedback. So the positive feedback is good, so it tries to maximize that reward based on the policy it devised from above. So this is how it maximizes the expected reward. Now, um, then comes, it tries to achieve no explicit programming. So reinforcement learning algorithms strive to identify the optimal policy without requiring explicit programming or prior knowledge of the dynamics. So it is all done within the environment. So basically, so even if you don't have much data and your environment is constantly changing, so based on your, so the reinforcement learning has the ability, by getting feedback rewards and by devising the optimal policy, it can give you the better results over time. So we don't have to explicitly program or set a rules on our own. It will do it on its own, which leads to its dynamic adaptation goal. like it aims to improve the policy based on feedback which receives from the environment, and it is all done through trial and error approach. So which then it comes to the autonomous decision making. So the end game is to empower agents to make autonomous decision by learning from their experience and interactions in the environment. So by this experience, like from the past experience, how well it performed, whether it got positive feedback, negative feedback, based on that feedback, it derives the decision making problem solving. Then it explores the environment, like environment exploration. So it involves, like, it discovers the most effective actions. So during the trial and error, it goes through lots of actions which leads to the positive negative feedback or anything. So it discovers the most effective actions, like which will get him the maximized expected reward. So like it explore, there is a concept of exploration and exploitation. So I will create a separate video on that, it is a broader topic. But for now, let's just get an overview. Like the environment exploration is, the aim is to get the balance between the exploiting known strategies and exploring new possibilities. So that's the environment exploration. Then comes the adaptive learning. So the algorithm reinforcement learning, it seeks to continuously adapt and refine the policy, ensuring it remains effective in the face of changing environment condition. No matter how the situation changes or your environment changes, like it would continuously learn, continuously optimize its policy to get the maximum expected reward. And like it's how it should get the, it should be the effective in face of in any like situation changes. So that's all the, there are many other goals as well, but these are the main goals of what reinforcement learning algorithm tries to achieve. So then these are all the applications where reinforcement learning can be applied. There are lots of applications, like this is just a sample of it. We can use it in robotics to train the robots for walking, grasping object, for cleaning floors, or navigating through environment, anything. So this could be done in robotics using reinforcement learning algorithm. Playing games, so like games like chess, starcraft, reinforcement learning has done a better performance, beating a world class champions as well. Then recommender system, we have already used Netflix, Amazon, all of this uses reinforcement learning. Yeah, it uses the content based filtering method and every other that. It also used in finance, like reinforcement learning is used to optimize the trading strategies. It is also used to make portfolios and whatnot. So and also used in transportation, like you've already seen the example of self-driving cars. So like Tesla, they, it's heavily used, heavily using reinforcement learning. So yeah, these are all the applications of reinforcement learning algorithms. Next, like for this video, we have covered the introductory part. In the next video, we will see what is Markov decision process, how it comes into the picture, what problem it solves, its application, advantages, what are its limitation, and every other stuff related to Markov decision process with its implementation and with, yes, real day example as well. So stay tuned, and yeah, thank you.